Those of you who have seen the two exhibition layouts we have, even if only on video, will be aware of the extensive use of lighting. Suitable use of lighting can mean the difference between having a train set or a model railway. And, of course, it looks so much different if you can dim the lights. We have a number of presentations on our website covering adding lighting to buildings. This includes PMP kits, which provide random lights. We also have a guide to making street lights. There are kits which enable us to flash Belisha beacons, have realistic traffic lights. But up until now, we haven't covered in any detail adding lights to road vehicles. We'll attempt to address that now. There is a very wide range of extremely detailed model road vehicles available to us. Here are just a few of the companies producing cars, buses, and commercial vehicles. Vehicles are available for most eras, so it should not be difficult to find suitable models for any layout. At the same time, you may wish to personalize vehicles to replicate vehicles that you've either owned or have been owned by members of your family, to provide added interest to your own layout. Here are the different types of LEDs that we'll be using to illuminate the vehicles. Microlith LEDs, 0402 size, are ideal for creating headlamps for 00 scale vehicles. Use warm white for period vehicles and cool white for modern vehicles. The red lighthouse style LEDs can be used for larger vehicle rear lights. And sections of 12-volt LED strips can be used for bus interiors. As with all forms of modeling, we need to proceed with caution. Observe appropriate safety measures when using sharp tools. Opening model vehicles may require the use of a mini drill to remove rivets. Small handheld drills may be required to drill holes for LEDs. And practice on low-value models. Having chosen the model we wish to modify, we need to open it. The easiest models to take apart are those which are held together by screws. Then we have what I refer to as the post method. Finally, we have rivets. In this particular example, this vehicle has both the post method and rivets. Rivets are by far the most difficult of vehicles to take apart, and I would urge you to use caution. This is the bus we will be using to demonstrate the techniques. It's manufactured by EFE. It's available in a variety of liveries, and it is modeled on a Harrington Cavalier. You'll recognize this shot from a previous slide. This is what I refer to as the post method of assembling the bus. There are 3 metal posts that are attached to the roof, come down through the body of the vehicle, and are held in place by plastic connectors. We need to remove those plastic connectors to release the various parts of the bus. Therefore, we need to carefully drill holes in the plastic to enable us to lever them out of the chassis. Here you'll see we have removed all 3, and once the 3 plastic inserts have been removed, the bus comes apart. You'll see the 3 posts, as I referred to, which are still attached to the roof section. Next, we remove the plastic glazing, put to one side, and carefully using a rotary cutting disc, we remove the posts. The center post needs to be removed to enable us to attach the lead strip, and the 2 outer posts, while not being in the way, are visible through the coach windows. Here we have the 3 posts removed. On this particular coach, you'll see that there are 2 openings for skylights. As a result of this, there are 2 clear areas in the glazing. To avoid the LED strip being visible through these openings, I've painted the glazing white. Here you can see the glazing has been reinstalled in the roof section, and a section of LED strip has been added. For those not familiar with LED strips, we are using a 12-volt version here, and all of the LED strips are capable of being cut into 3 LED sections, which is ideal for this size of bus. The LED strip has simply been glued to the underside of the roof section, and leads soldered and taken out towards the rear of the roof. We then turn to the most difficult part of the exercise. Most vehicles tend to have metal headlamps. We need to drill a 1mm hole through the dead center of the headlamp using a pin vise. If you do drill a hole which is slightly off dead center, you can usually rectify that by carefully elongating the hole. Once you have drilled the required number of holes in the headlights, you then take a drill bit slightly smaller than the maximum diameter of the headlamp, and then just with a few turns create a concave surface. This replicates the reflector of the real headlamp. Having created the holes, we then insert the first of the microlit LEDs. I have added headlights to literally dozens of vehicles without any issues until the most recent batch of microlits LEDs. The manufacturing process was slightly different, and the exposed contacts where the wires are soldered to the LEDs caused a couple of short circuits. To avoid this, I used fine heat shrink to insulate the contacts around the LED. You must ensure that the LED protrudes sufficiently to avoid the light being obscured by the heat shrink. Here we see the chassis of the bus. We have the 4 headlamps on the left-hand side, and we've also added 2 rear lamps on the right. I'm using 2 of the holes vacated by the metal posts to insert the leads down through the chassis of the bus. If these aren't available to you, then simply drill an additional hole. We then turn our attention to the headlights, and here I'm finishing them by using glue and glaze. Once this product dries, it dries crystal clear and essentially forms a glass headlamp. Now we have the passenger compartment. There is no point adding lighting to a vehicle if it's empty. Although this is a 00 scale vehicle, I'm using HO scale passengers, as they are far more easy to fit into the vehicles than the standard 00 scale. Also, you may find that the plastic material of the vehicle is not particularly easy to adhere to. I usually abrade the surface and then use a combination of super glue and an accelerator to hold the figures in position. Next, we will take the leads from the LED strip in the roof section and feed them through a hole in the base of the chassis. We're now ready to add the passenger compartment, and then using small amounts of super glue, we then reassemble the vehicle and hold it in position until it's completely set. Using super glue, I've found that 5 minutes is usually sufficient time for the joint to be made. Then it's simply a matter of adding dropping resistors to the LEDs. And in this case, we have 2 different types of LEDs. For the microlith LEDs, I'm using a 30K resistor. For the 12-volt LED strip, I'm using a 5.6K resistor. But it's personal choice, and you can vary those values depending on the level of illumination you need. Once you have added those dropping resistors, protect the wiring with heat shrink. And here's the finished coach with its headlights and interior lights on. In reality, the lighting intensity inside the coach is not as high as the image would suggest. But if you do find that the lighting intensity is too high, you can always increase the value of the dropping resistor. Finally, here we see the rear lights of the coach. They are, of course, the same microlith LEDs that I used for the headlamps. These have been merely painted with red acrylic and finished off with glue and glaze. Double deckers are treated in the same way. It just requires a bit more work. This is one of my favorite models. This bus happens to be a Sunderland corporation, Guy Arab of the 1950s. In this particular service, Used to take me down to my local beach with my bucket and spade. It's also a model that utilizes 3 posts plus 1 rivet at the rear. Once they've been removed, the bus comes apart as shown. Technique exactly the same as that for the previous example. Here I've added lead strips into both passenger compartments. There is no significance in the difference between the 2 lead strips. They're both 12 volts. They just happen to be what I had handy. Note the wiring. All vehicles are different, and you need to route the wiring so that it will emerge from the chassis of the bus as unobtrusively as possible. Once again, we have the passenger compartments, now populated with figures. Here we have a piece of good fortune. This particular model uses clear plastic lenses for the headlamps. No drilling required. We simply glue a microlith to the back of each headlamp lens. Then it's just a case of reassembling the model. And here we have it, ready to go off to the beach again. I think you'll appreciate that the use of interior lights really highlights the interior of the bus, the passengers, the seats, as it would be in real life. Emergency vehicles give us the opportunity to add flashing lights, even more so to modern era emergency vehicles. For flashing lights, we can use the PMP21 dual LED flasher. Here are some typical examples. The ambulance has 2 microlith LEDs as headlamps, and a 3rd microlith LED is just glued to the underside of the blue light and powered by a PMP flasher kit. Here we have a fire engine that is treated in exactly the same manner. In addition, the fire engine has been fitted with an interior light. Now we can see the emergency vehicles in action. I mentioned earlier that we can customize vehicles to replicate those which we may have driven in the past. This is one such case. It's a model of a Leyland 550 FG, and I used to drive one of these in my student days as a holiday job. To create this vehicle, I simply bought a white Leyland 550, carefully removed the transfers, and fortunately I was able to obtain the exact set of transfers I needed from a specialist supplier to complete the job. The image on the right demonstrates the use of the lighthouse LEDs to form rear lights. Simply paint the body of the LED with sufficient coats of black paint to prevent light bleed, and leaving the rounded section exposed to form the red rear lights. In the case of commercial vehicles, there isn't any need to hide the wiring as it would be seen on the real-life vehicle. Here are a couple of smaller commercial vehicles that have received the same treatment. This is another customized vehicle. In this case, it's the van that my dad used to drive. Simply add the lights, create a set of number plates, and create a set of simple transfers. Lights can also be added to moving trams. In this case, I'm using a plastic kit, Sunderland tram car, with two motorized bogies. This tram runs on my layout using the P&P shuttle kit. Automatic reversible front rear lights can be added using bi-color LEDs. Power is taken from the track and converted to the appropriate voltage. A PMP8 unit, the multi-purpose flasher, can simulate pantograph flashing. Here we have the film in action, coming towards us. In the reverse direction, you'll see that the light has turned to red. I hope this has helped to show how you can really enhance your model railway with a bit of practice.